Greetings to Puan Susanna and my fellow friends. My name is Ang Seong and I'm from DTP 4A. My matrix number is 10 DTP 21F 2007. My group member is Yugendran and Lugendran. The title of our group is Electro Discharge Machining Process.
Hello, my name is Sugenden, son of Krishnan. I am from class DTP 4A. My matric number is 10 DTP 21F2003.
Okay, my name is Yogendran, son of Patnagar. My matric number is 10 DTP 21F2005 and I'm from DTP 4A. Okay, the introduction of the EDM process is the removal of a material from a workpiece using EDM occurs through a series of recurring rapid current discharge between electrodes. These electrodes are separated using a diselectric fluid. That a voltage is sent through the electric fluid. It is important to note that EDM manufacturing only works for electrically conductive materials. One of those electrodes serve to change shape to the fit exact purpose. This electrode is the workpiece electrode or the anode. The other electrode is the tool electrode or the cathode. The basic principle behind his process is the erosion of the material with a controlled electric spark. For this to occur, the two electrodes must not come in contact. There is the application of potential differences across the workpiece and the electrode in pulse form. As the electrode moves closer to the workpiece, the electric field present in the small gap between them increases. This continues until it reaches breakdown volume.
Principle of Operation Process Conceptual. The first serious attempt at providing a physical explanation of the material removal during electric discharge machining is perhaps that of Van Dijk. Van Dijk presented a thermal model together with a computational stimulation to explain the phenomena between the electrodes during electric discharge machining. However, as Van Dijk himself admitted in his study, the number of assumptions made to overcome the lack of experimental data at that time was quite significant. Further models of what occurs during electric discharge machining in terms of heat transfer were developed in the late 80s and early 90s. It resulted in 3 scholarly papers. The first presenting a thermal model of material removal on the cathode. The second presenting a thermal model for the erosion occurring on the anode. And the third introducing a model describing the plasma channel formed during the passage of the discharge current through the dielectric liquid. Validation of this model is supported by experimental data provided by AGIE. These models give the most authoritative support for the claim that EDM is a thermal process, removing material from the two electrodes because of melting or vaporization, along with pressure dynamics established in the spark gap by the collapsing of the plasma channel. However, for small discharge energies, the models are inadequate to explain the experimental data. All these models hinge on a number of assumptions from such disparate research areas as submarine explosions, discharge in gases, and failure of transformer. So it is not surprising that alternative models have been proposed more recently in the literature trying to explain the EDM process. Among these, the model from Singh and Gauss reconnects the removal of material from the electrode to the presence of an electric force on the surface of the electrode that could mechanically remove material and create the craters. This would be possible because the material on the surface has outer mechanical properties due to an increased temperature caused by the passage of electric current. The author's simulation show how they might explain EDM better than a thermal model. Melting or evaporation, especially for small discharge energies, which are typically used in micro EDM and in finishing operation. Given the many available models, it appears It appears that the material removal mechanism in EDM is not yet well understood and that further investigation is necessary to clarify it, especially considering the lack of experimental scientific evidence to build and validate the current EDM models. This explains an increased current research effort in related experimental techniques.
Now I'm gonna talk about machine parts and components in EDM machine. There are a lot of parts and components in EDM machine. As you can see the above picture, now I'm gonna list it out. First, filter, pump, electro tank, and flushing nozzles.
Now, we will share a video about the working principle of electro discharge machining process for better knowledge.
As erosion continues, the machine controls advance the electrode through the work, always maintaining a constant gap distance between it and the workpiece. To understand how EDM removes metal, let's examine a single spark in the erosion process. As a pulse of DC electricity reaches the electrode and part, an intense electrical field develops in the gap. Microscopic contaminants suspended in the dielectric fluid are attracted by the field and concentrate at the field's strongest point. These contaminants build a high conductivity bridge across the gap. As the field's voltage increases, this material in the conductive bridge heats up. Some pieces ionize to form a spark channel between the electrode and the workpiece. At this point, both the temperature and pressure in the channel rapidly increase, generating a spark. A small amount of material melts and vaporizes from the electrode and workpiece at the points of spark contact. A bubble composed of the gaseous byproducts of vaporization rapidly expands outward from the spark channel. Once the pulse ends, the spark and heating action stop, collapsing the spark channel. Dielectric fluid rushes into the gap, flushing molten material from both surfaces. This EDM residue consists of small solidified balls of material and gas bubbles.
To talk about application of the machine process, EDM is particularly famous in small volume production, which makes several processes possible. These processes include milling, turning, and holes, drilling, and more. This unique process is also valuable for a wide range of industry ranging from automotive to the aerospace industry. Being able to create unique and precise shape, this technique helps in the following applications. This injection molding. Achieve the right dimension, depth, and shape of mold is usually depend on EDM. It is the major injection molding process used by mold manufacturers. Why EDM is the main type used in this case. Injection molding application of electrical discharge machine, since injection molding require various delicate and complex workpieces. This is usually the best method to use. Moreover, the often process high precise and fine EDM surface finish. Some small hole drilling. Electrical discharge machine is a quick and unique way to create accurate and deep small holes drilling in materials, regardless of their hardness. EDM for small hole sinking. The whole drilling process involves using a brass electrode tube to channel the electrical discharge into the material. This helps to create holes of various small dimensions. The exciting thing is that it can make holes on inclined face and other challenging positions. Die casting. EDM is also very suitable for die making application. Manufacturing highly tailored die required extreme accuracy. This die features shape, internal corner, deep dips, and other intricate features. Electrical discharge machine for die casting also die often made from very hard steel alloy. These alloys are usually harder to machine with traditional methods. The hard steel alloy may require finishing period to heat treatment, which may reduce the accuracy of details. Therefore, employing the EDM process is more appropriate. The advantage of EDM is it can be applied to all electrical conductive metals and any complicated shape that can be machined. Machine time is less than conventional machine processes. It can be also employed for the extremely hardness workpiece. No mechanical stress is present in this process because of no contact between the tools and the workpiece. No burners. Tolerance range plus minus 0.005 can be achieved. Good surface finish can be attained. Creating small holes is not easily achieved by any other process other than EDM. Fragile and cylinder workplace can be machined without distortion. The heat treatment process can be eliminated. The advantage of EDM is machine time is too long. Extensive tool wear, high specific power consumption, profile machining of complex conductor is not possible. Only able to machine conductive material. The material removal rate is slow. Reproduction of shape corner is the limitation of the process. Surface cracking may take place in the some material owing to their affinity to become brittle at room temperature, especially when higher energy per press is used.
So that is the end of electro discharge machining process. Thanks for watching the video.